Hey, how are you doing? We want to talk about properties of equality again. So if you didn't watch the last video on solving equations using properties of equality, addition, subtraction, go check that one out because you need all those skills to do this. But we're going to move on with more properties of equality. So we discussed before that you can add the same number on both sides of an equation. You can subtract the same number on both sides of an equation. Well, you know what else you can do is you can divide by the same number on both sides of an equation. So I have my scales again, and I have 40 pounds on each scale, so obviously it's balanced, right? Well, what if I took these 40 pounds over here and divided it by 2? That division would drop that down to 20 pounds, and what's going to happen is this side's going to hit the floor, right, because it's heavier. So what do I do to keep it balanced? I also divide the right side of our scale by 2, and then there we would go. It would go right back up, and it would be balanced again. So that's what I want you to always keep in mind. Whatever you do to one side of the equation, like, for example, divide by some number C, you must do to the other side of the equation. Now, there is one little extra detail, is that in this particular case, C is not allowed to be 0. Because remember, we can never divide by 0. But whatever we do divide by, as long as it's not 0, you have to do it on both sides. So let's do some problems where you get to see that in action. So what do you think about these? I've got first one, A, solve for x if 5x is equal to 45. Now you could guess. You could just guess what that number, what number does x need to be so that when you multiply by 5 it gets 45. And most of you know that's 9. But the real way to do it is divide the left side by 5 because you're doing the opposite operation. If you're multiplying to get this x isolated, remember, which is all by itself, you must get rid of that 5. To get rid of that 5, you do the opposite. And the opposite of multiplying is dividing. But if I do that on the right, I have to do that on the left as well. So this 5 divided by 5 just cancels. That gives me 1. And then the x is still there. Then 45 divided by 5 is 9. And just like always, we could check this. So does 5 times 9 equal 45? Well, sure it does. Well, I could try it again. Here I'm trying to get this z isolated. So to remove the negative 12 that's being multiplied by the z, and again, notice that's multiplication. It's not subtraction, okay? I'm not going to add 12 to both sides. I'm going to divide by negative 12 to get rid of the multiplication by negative 12. So if it's a positive, you divide by positive. If it's a negative, you divide by negative. And I have to do it to both sides, just like the scale says. I've got to keep it balanced. The negative 12 divided by negative 12 is z. That leaves the z only. And you know negative 36 divided by negative 12 is positive 3. So my solution is positive 3, but I could check it by saying negative 12 times 3. Is that really negative 36? Well, it certainly is. And then the last one on this page, again, I'm trying to isolate this a. I want that a by itself. Well, you should always ask what's happening to the a as it sits there. If you don't, you're going to make mistakes. What's happening is there's a 6 times it. What's the opposite of multiplying or times is divide. So the opposite, I'm going to divide by 6. I'm going to divide by 6. I do it over here to get rid of the 6 so the a is isolated. I do it over here because the property of equality says I must do it to both sides. The 6 is canceled, so I get a is equal to, and we know negative 48 divided by a positive 6 is a negative 8. And once again, I could check 6 times negative 8 is negative 48. That checks out. Now, D is really just like A, B, and C that we did. The only difference is it's got decimals. Now, if you've got a calculator on you, that is really nothing to be concerned about at all. I need to get rid of this 0.25 or 25 hundredths that's times this Z. So to get rid of multiplication, I do the opposite. I divide by 25 hundredths on both sides of the equation. Those cancel to leave me with Z on the left. And then in your calculator or using long division, remember we talked about that in the decimal section, 3.25 divided by 0.25 is 13. Okay, so I get z is equal to 13. That is my solution, but just to check to be sure, in my calculator, I'm going to type 0.25 times 13 to make sure that really is 3.25. That means that you can make 100 easily on this test because you can check every single result. Now, look at example E. It does look different. First of all, find your variable. I see him. He's over here. He's called A. Well, I have to get A isolated. Then I ask myself, well, why is it not already isolated? And then I say, well, because it's being multiplied by negative 11. Well, how do I get rid of multiplication? Aha, I divide. So I must divide the left side by negative 11, which means I also divide the right side by negative 11. Is it okay if my variable's on the right? It sure is. So my A comes down, and then negative 121 divided by negative 11 is a positive 11. You could check it by saying negative 121, does that really equal negative 11 times 11? And you can multiply in your calculator, and you definitely will see that that's true. So to recap, when I look at these problems, what I do is I find my variable first. If there's a variable on both sides, I've got extra work to do. If any side needs simplifying, I have extra work to do. Well, look, everything is simplified. There's my variable right there. I'm trying to get that variable all by itself. So I have to determine what's happening to the z right now. Well, it's being multiplied by negative 14. How do I get rid of multiplication? I divide. And so that I'm following my properties of equality, I do it on both sides. Now, negative 14 divided by negative 14 is 1. That's the reason they cancel. I still have a z. What is 0 divided by negative 14? First of all, can I even do that? Sure you can. Properties of 0 say that 0 divided by a number that's not 0 is 0. What you can't do is divide by 0. If the negative 14 were 0, that's not allowed. Okay, so the answer is 0. Check it. Is negative 14 times 0 equal to 0? Well, sure it is. Yes, that's totally right. Well, look at G. It's got its own issues, right? Now, I'm not done with G. I can't say that's finished because it's not. The X is not by itself. It's got a negative in front of it. Now, secretly, we know what's going on with that. That's really the same as saying negative 1x is equal to 42. That negative 1 is being multiplied by x, so to get rid of the negative 1, I'm going to divide by negative 1. I must do it on both sides. The negative 1's cancel, and I get x is equal to 42 divided by negative 1 is negative 42. Let's check it. Alright, so I take that negative 42 and I plug it in right here. So there's a negative already in my problem, and then I plug in negative 42. Is that really equal to positive 42? And you know what it is. This is the opposite of 42, which is just 42. So it checks out just fine. This looks different. So what do we think is happening here? Well, first of all, remember the things we're looking for. Is there a variable on both sides of this equation, h? And there's not. There's just a little old variable right here, okay? And he'd be happy if we could get rid of that 3. Now the question is, how am I going to get rid of that 3? And I'm going to recopy it so we have a little bit of room to work here. Okay, that's our problem just rewritten. Now this 3, what is it doing to the x? Well, most of you are saying it's a denominator. Is dividing into the x, right? That really is x divided by 3. How do you get rid of division? What do you think you would do? Multiply, right? So let's multiply the left side by 3. That means I'll have to also multiply the right side by 3. This is the multiplication property of equality. If you multiply on the left by a number, you must multiply on the right by that same number. Now on the left, the 3's cancel, and I'm left with just x equals, and on the right, 35 times 3 is 105. Now we could check it by plugging in 105 up there in the aqua highlighted area for x. 105 divided by 3, is that really equal to 35? And that is worth checking. 105 divided by 3. Yes, that is definitely equal to 35. Here we go again where I threw the variable on the other side. Is that okay? Sure it is. It's not a problem at all. Probably didn't mean to put a 3 under there as well, but it works the same way. Even if it's on the other side, we need to multiply both sides by 3. So watch, I'm going to rewrite the problem for space purposes. And I want to multiply the right by 3. And I have to multiply the left by 3 as well. You notice me throw those parentheses around the negative 15. Why did I do that? Because it's multiplication. If I didn't, it would look like 3 minus 15. And that's not what it is at all. It's 3 times negative 15. Now on the right, the 3's cancel, and that leaves me with just x, which is exactly what I want. And 3 times negative 15 is negative 45. We know a positive times a negative is a negative, and 3 times 15 is 45. We could certainly check it by taking the negative 45 and plugging it in right there. So I have negative 15 is equal to negative 45 divided by 3, and that is definitely negative 15. That checks out. This is very similar to the last page, to the point where it's probably worth pausing the video and just making sure you get the same answers as I do on these. I'm going to rewrite this problem for space purposes. So I have z divided by negative 8 equals 101. Now I'm trying to get this z by itself, which means I got to get rid of that negative 8. It's being divided, so I want to do the opposite and multiply. I want to multiply the left side by negative 8, and I want to multiply the right side by negative 8. Now this negative 8 and this negative 8 cancel. So I have z is the only thing on the left, which is what I want. And then 101 times 8 is 808. And a positive times a negative is a negative. I can certainly check that by plugging in negative 808 in for my z divided by negative 8. And I promise you, you will get 101. This is different only because my variable's on the right. Is that okay? It certainly is. I still have to isolate it. So I'm going to multiply the right side by negative 3 and the left side by negative 3. And then negative 3 times negative 25 on the left is a positive 75. We know a negative times a negative is a positive, right? On the right, the negative 3 cancels, so I just get x as my answer. Again, I could check it by saying, is negative 25 equal to positive 75 divided by negative 3? And it definitely is. A positive divided by negative is a negative, and 75 divided by 3 is 25. Aha! Now these are where it gets more interesting. Okay? So whenever you have a fraction, there's a couple of ways you could think about that. You could think about that x right here on L is being multiplied by 4 and divided by 5. So I want to do the opposite. I want to divide by 4 and multiply by 5, which really is multiplying by the reciprocal. So watch this. I'm going to multiply the left side by 5/4. See what I did? I just flipped the fraction upside down, multiply the reciprocal. And the right side also has to be multiplied by 5/4. Now on the left, why did that do any good? Well, look, this 5 cancels with this 5. This 4 cancels with this 4, and that does really just leave me with x on the left. Now on the right, we're just multiplying fractions together. That 16 is over 1. I can simplify before I multiply because 4 goes into both 16 and 4. 4 goes into 4 once. 4 divides into 16 4 times. I can say 4 times 5 is 20. And 1 times 1 is 1, which I don't write in the denominator because completely simplified would be x equals 20. To check it, I would say 4/5 times 20. Is that really equal to 16? And it is, because 5 goes into 20 4 times. 4 times 4 is 16, and that equals 16. Yes. Okay. Well, what happens when the fraction is negative? And this one I'm just going to rewrite so I have a little more room. So what happens when the fraction is negative? Well, you've got to get rid of the negative as well. So if you multiply by negative 6/5 on the left and negative 6/5 on the right. Now, why the negative? Because a negative times a negative turns positive, and we need that z to be positive, right? Are we sure? this works like this 6 cancels with this 6, right? This 5 cancels with this 5, and the negative times the negative is a positive. Yes, that's just plus z. Now on the other side, let's put that over 1. I can pre-simplify because this 5 goes into 5 once, and then we got a 5 into negative 50 is negative 10. And then you could say negative 10 times negative 6 is positive 60. So my solution is 60, but just to be sure, let's check it. So negative 5/6 times 60, is that really equal to negative 50? That's the question. Now, we do know that 6 goes into 60 10 times. Negative 5 times 10 is negative 50. Sure, that checks out just fine. Again, more fractions. Don't let these fractions problems bother you, okay? I'm going to rewrite this one. Maybe I need more space. Negative 1/2 z. So first of all, I'm trying to get this z by itself. Which you know what that means. That means I need to get rid of this negative 1/2 right here. So what do I multiply by? The reciprocal and the same sign, right? So I'm going to multiply by negative 2 over 1 on the right and negative 2 over 1 on the left, right? Now, is that right? Well, the 2's cancel because there's a numerator denominator. The 1's cancel, numerator denominator. A negative times a negative is a positive. Yeah, that just leaves me with z over there. And what about on the other side? Well, the other side, I am multiplying negative 2 times the positive 16. Remember that 16 is really over 1. That's going to be a negative 32 over 1, which is just negative 32. And you could certainly check it by saying 16. Does that really equal to negative 1/2 of 32 negative? And it is, because half of 32 is 16, and negative times the negative is a positive. Yep, that's right. Okay, now again, first focus and find your variable. And you may have more than one. If you have more than one, you have to figure out, do you need to get them all on the same side? Or do you need to simplify a side? Well, there's only one variable right here. We don't need all that mess. We just got to get rid of the negative 7/12, right? Well, to do that, I multiply by the reciprocal, the same sign. So I'm going to multiply negative 12/7 on the right, and it's a mess. This is multiplication, negative 12, it won't even let me write, negative 12/7 on the left. You see that? Now let's look at the right, just to make sure we're doing this right. This 12 and this 12 cancel. This is multiplication. This 7 and this 7 cancel. This negative times this negative is a positive. So all I'm left with is y. That's good. Now on the other side, I can simplify. I know it's hard to see, but 3 goes into 12. So 3 goes into 3 once, 3 goes into 12 4 times. Now I still have a negative 4 in the numerator times a negative 4 here. A negative times a negative is a positive. 4 times 4 is 16. And the denominator, I still have this 7 times this 1, which is 7. So y is equal to 16/7. Now it's really hard to go back and check this because I wrote all over my original problem. But my original problem reads negative 4/3 equals negative 7/12 times y, and y is 16/7. Let's check it. Now first of all, to check, I see that my 7's just cancel. And that gives me negative, still there, 16/12. Y'all, negative 16/12. 16 and 12 both divide by 4. So 16 divided by 4 is 4. 12 divided by 4 is 3. And there's the negative, and look, that matches the left-hand side. So it's totally correct. Now let's stop and think about what's going on in this big problem. It looks different, right? I see that my variable is over here. Matter of fact, it's z, z, z. It's not in one spot. And on the other side, I can simplify too. So let's focus this on like two different expressions. I've got this expression that needs simplifying, and that needs simplifying. So first of all, what's negative 18 minus 5? If you're having trouble with your sign numbers, remember you keep your first one, you change subtraction to addition, and you change the sign of the next number. So negative 18 plus a negative 5 is negative 23 equals. On this side, I've got 5z minus 9z, or plus a negative 9z, which is negative 4z, plus a negative 6z, which is negative 10z. Make sure you see that. You can just do that in your head. 5 minus 9 is negative 4. Negative 4 minus 6 is negative 10. So the second line is really what we're doing. Now remember, we're trying to get this z by itself. What's happening to that z right now? Well, it's being multiplied by negative 10. How do we get rid of multiplication? Well, we divide. So I divide the left by negative 10. If I do that, I said that backwards. The right by negative 10. I also divide the left by negative 10. Now, the negative 10s cancel. So I'm left with z on the right side. And then, yuck, I can't divide 10 into 23, can I? Well, it's just that. It's 23 over 10. It's a fraction that will not reduce further, and the negative divided by the negative is a positive. That is your answer. Now, checking that, not quite as much fun. So I go back to my original, or even in the original, I always say check your original, but even in the original, I'd have to do all this work. So I'm going to check it in the second one. Negative 23, is that equal to negative 10 times 23 tenths? So the 10s cancel over there. That's negative 23 equals negative 23. It definitely checks there. But we would be good to go back and check it here, but that certainly is a lot more work. So I verified that this was right and this was right and used that as a check. It's sort of cheating, but it saved us a little bit of time and fraction work. So kind of got to decide what's best. Wow, now what do we do here? I got 5/12 A plus 1/2 A equals 25 minus 3. Now I do know on the right, 25 minus 3 is 22. Okay. On the left, these are like terms. They're both A's. So I need to add 5/12. I'm going to do it over here on the side. Plus 1/2. Do they have a common denominator? Well, not right now, but 12 would work, wouldn't it? So 5/12 just stays 5/12. But 1/2, well, to make that a 12, down here, I need to multiply the denominator by 6, and if I do that, I have to multiply the numerator by 6 as well, so that's basically 6/12. So when I add those, I get 11/12. So why did I add those? Because those are the A's, so I have 11/12 A. Now, you ask yourself, what's happening to the A? Remember, I'm trying to get this A by itself. Well, it's being multiplied by 11/12, so how do I get rid of the 11/12? I multiply by the reciprocal. So I multiply by 12 over 11 on the left and 12 over 11 on the right. And what's going to happen is my 11s and 12s cancel. So I'm left with A only. It means A is isolated. And over here on the right, that's over 1. I can say 11 goes into 22 2 times. Numerator times numerator is 24. Remember, that's a 1 down there. Denominator times denominator is 1, but I don't have to put that over 1 because 24 over 1 is just 24. And again, I could check it by plugging in 24 into my A value both times. This time I'm going back to the original because you really should. And 25 minus 3 now is 22. We're confident with that. Now, 12 goes into 24 twice. 5 times 2 is 10, plus 2 goes into 24 12 times. 1 times 12 is 12, and 10 plus 12 is 22. So they look more complicated, but the method is the same, right? Well, what if you have the same issue going on, but with decimals? So look at the left side, just all by itself. I can combine that together. I have like terms. I have the lazy lady, 0.05, or the real way is 5/100ths, K, minus 1/100ths, K. Now, y'all know 0.05 minus 0.01 is 0.04 K. I just combine like terms equals 2 plus 0.24 is 2.24. And that's my real problem right there. Now I'm trying to isolate this K. I want it all by itself. Well, what's happening to it right now is it's being multiplied by 0.04. To get rid of that, I'm going to divide by 0.04 on both sides of the equation. Those cancel. That gives me K is equal to, let's try this again, K is equal to, now 2.24 divided by 0.04 is 56, actually. And you could check it by doing 0.05 times 56 minus 0.01 times 56, and does that really equal 2.24? I definitely suggest a calculator on this check. And hey, make sure you know how to do the checks too, because a lot of people have trouble plugging stuff in their calculator. Matter of fact, when I checked it this then, I didn't get it right, and I'll tell you why. It's because I didn't subtract. I got it the second time, but I added right here instead of subtraction, but it worked out just fine. Hey folks, what would you like to do with this one? See, you've got to use the distributive property, right? Because you've got this b minus 5 that's multiplied by this negative 12. I would go ahead and subtract 5 from b, but I can't because I don't know what b is. So I must, there's no option, I must distribute that inside. Okay, so let's start there, one thing at a time. Negative 12 times b is negative 12b, right? Now here's where things get sticky. I know this takes practice. Think about this as negative 12 times negative 5. I know that's a minus 5, but if you take the negative with the 5, it's like saying plus a negative 5, and that's easier to work with, I promise. So think about this as negative 12 times negative 5, which is a positive, so I put plus 60. This minus 29 that's right here, I'm just going to recopy, and 43 I'm definitely going to recopy. Okay, now we're still focusing on the left side because the left side is not completely simplified yet. This 60 minus 29, I can still go ahead and combine like terms. Now I can't do anything with the negative 12. It stays negative 12. But 60 minus 29, we know is 31. And it's a positive 31, so I put plus 31 is equal to 43. Okay, now this is what we call a two-step problem. And we actually have not learned this yet, so this is kind of a prequel to the next section. But let's go ahead and talk about it. You're trying to isolate this b right here, right? I'm trying to get that b by itself. Well, to do that, I must remove this 31 and remove this negative 12. The true question is, which one do I do first? Well, you're actually undoing order of operations, if that makes any sense. So the first thing I'm going to do would be the last thing I would do with order of operations, which is addition and subtraction. So remember, put the line to keep our equals lined up. I'm going to subtract 31 and subtract 31. Remember, if I do it on the left side of the equation, I must also do it on the right side of the equation. Okay? So this 31 cancels with that one. I still have a negative 12b on the left-hand side, and I have 43 subtract 31 is what, 12 on the right-hand side. Now, I got to remove this negative 12. I need to remove the negative 12. How do I do that? Well, again, ask yourself, what's happening to this b right here? Well, it's being multiplied by negative 12. What's the opposite of multiplying by negative 12? You guessed it, divide by negative 12. If I divide by negative 12 on the left, I must divide by negative 12 on the right. So notice when you multiply and divide, you divide by the same sign. When you add and subtract, you're doing the opposite, because the opposite of addition is subtraction. But when the opposite of multiplication is division, and you're dividing by that entire number, the negative and the 12. So the 12s cancel and the negatives cancel. And that leaves me with b on the left. And what is positive 12 divided by negative 12? We know that's negative 1, correct? Now we could check it. It's a good idea. Negative 12, parentheses. Remember, I'm removing the b and replacing it with what my answer was, which is negative 1. So negative 12, parentheses, negative 1. Oh, I closed my parentheses too fast on the right. Minus 5, minus 29. Is that really equal to 43? Okay. Now, I don't have to distribute here because this can be done. I'm doing my, please excuse my dear Aunt Sally, order of operations first. Negative 1, and then I can keep change. Now, what is negative 1 plus a negative 5? Well, that's negative 6. The minus 29 comes down. Now, multiplication comes before subtraction. Again, I'm just doing order of operations. Negative 12 times negative 6 we know is a positive 72. Subtract 29, and finally, is 72 minus 29 43? And it is. So you get 43 equals to the 43 that was on the other side the whole time. Yay, we got it right. Now, we've got some word problems to do. Remember, we're translating algebraic phrases, which are now equations, and then we're going to solve them. So, 187 is, now is means equals the product. What does product mean? Remember? It's multiply. Yes. So, the product of negative 17 and m. So basically, we have 187 equals negative 17m. So your next step is to solve. So I'm trying to get this m by itself. Now you tell me, what's happening to that m right now? Well, it's being multiplied by negative 17, right? So how do I get rid of that? Well, I divide by negative 17. So if I divide this side by negative 17, which is the right side, I am required to divide the left side by negative 17 as well. Now, the reason I did it over here is so those would cancel. The negatives cancel and the 17s cancel, because negative 17 divided by negative 17 is just 1. Now, that's on the right side. On the left side, what is 187 divided by 17? I don't know if that divides in there evenly or not. We could do long division, but don't make me. Ooh, it does go in there evenly. It goes 11 times. I just used my calculator and I did, let me show you, 187 divided by 17. That's what I typed in. And it gave me 11. Now, that's not my answer. My answer is negative 11. Why is it negative 11? Well, because I did a positive divided by a negative. I didn't bother to put that in my calculator because we know the rules, right? But that is negative 11. Now, you could check it by just plugging in negative 11 right here. Is 187 equal to negative 17 times negative 11, and it is. Okay? Oh, I didn't do it in green. Let's just pretend like that was in green. That's my green check. All right. Keep going. Almost done with this video, by the way. It says u divided by 7. How do I write that? U divided by 7 is equal to, that's pretty clear, negative 49. There we go. Now, you could have written u divided by 7 is equal to negative 49. But we're trying to get rid of this division symbol because it's weird when you're working with algebra. In this case, in fraction form, we know what to do. Just multiply this side by 7 and multiply this side by 7, right? Because when you divide, the opposites multiply. Those 7's cancel. And I get u is equal to, and then I'm just going to use my calculator to multiply 49 times 7. And when I do that, I get 343. But is my answer positive or negative? Well, a negative times a positive is overall a negative. So that's the case. And then check it. I could just type in my calculator, negative 343 divided by 7. Does that really equal negative 49? And it does. Okay? Yay, we made it to the last page of the video. So the quotient of h and 26 is negative 52. Now we know is equals. We know that part. What in the world is quotient? Quotient means to divide, right? What order? Well, exactly as it's written. So the quotient of h divided by, I'm going to use a fraction bar again, 26 is, which is equals, negative 52. Now I just need to solve it. So if we're dividing by 26, and I need to get rid of dividing by 26, what do? I multiply by 26 on both sides. It's going to be a big answer. So those cancel, so I have h is equal to, and on the right I need to multiply 52 times 26, and I get 1,352 is my answer. Is that right? Am I leaving off anything? What's a negative times a positive? It's a negative, yes. And you could check it by just saying negative 1,352 divided by 26. Is that really equal to negative 52? And it is. Okay? And then my favorite. You really do need to know this bottom one. Okay? It says 4/3 of W. Now, of in math almost always means multiply. And it definitely does when it's a fraction. So you got 4/3 of W is 36. There's your problem right there. 4/3 of So that's times W equals 36. Now, how do I get rid of that 4/3? You know what to do. Multiply this side by 3/4 and multiply this side by 3/4. Remember, that's how you deal with fractions. When you're multiplying by a fraction and you want to get rid of it, you multiply by the reciprocal. So the 3's cancel, the 4's cancel, so I have W on the left. Now over here, that 36 is over 1. You agree? And I can go ahead and say 36 times 3 in the numerator and 1 times 4 in the denominator, but I do know that 4 and 36 reduce. They both divide by 4. So what I'm going to do is say 4 divided by 4 is 1, 36 divided by 4 is 9, and then I multiply 9 times 3 to get 27 over 1 times 1, which is 1 in the bottom, and we don't have to write that. And we could check it by saying 4/3 times 27, and we're just checking to make sure that's 36. And to remind you again, that 27 is over 1. I can simplify this numerator denominator by dividing each by 3, and you get 4 times 9 is 36 over 1 times 1 is 1, which is definitely equal to 36. Hope this went well for you. Practice is key. Watching me do them, I know it can seem pretty easy, especially if I would slow down a little bit, right? But you've got to do them on your own to realize what does make sense and what doesn't make sense. So I hope it goes well for you in the homework, and I'll see you next video.